Okay, everybody, here we go. We're going to do an introduction to quadrilaterals, right? Okay, the idea is going to depend on these definitions. Okay, so we know a quadrilateral is a shape that has four sides, right? The quad means four, and lateral meaning sides. Okay, so we're learning about a lot of different quadrilaterals here. Okay, this video is mainly going to be about this assignment, Intro to Quadrilaterals, but there's going to be another video after this that breaks down a little bit more of the details. Okay, for today I'm just making a quicker video to go with this specific one that does cover some of the basics at the same time. Okay, so this would be a good time to pause it to write down these definitions. If you were absent, this is very important. Okay, you want to know all of these, and then I did give everybody this table of information that we were going to organize, and so you should also fill out that table, the study guide for quadrilaterals too. Okay, so we have parallelograms that are made of parallel sides, two pairs of parallel sides, and we have rectangles that are basically a parallelogram where all four angles are right angles. And then we have a square, which we know it's a rectangle where all the sides are equal. We have a rhombus, which is a quadrilateral where all the sides are equal, so all four of them are equal to each other. Then we have the kite and the trapezoid, which are a little different. Okay, the trapezoid has only one pair of opposite sides, where the kite has two pairs of sides that are equal and they're next to each other, and that's what adjacent sides means. Okay, so we'll be looking at some examples of these right now. Let's take a look at the quadrilateral hierarchy here. Okay, we have this idea of every four-sided shape counts as a quadrilateral. We can kind of see the family tree here. Okay, we can see that parallelograms have some different kinds of parallelograms. Okay, we have rectangles is one kind of parallelogram. Okay, and then you can see that we also have different rhombi, that some rhombi might count as parallelograms also. Okay, so when we look through, we see that we have trapezoids, okay, are a separate branch from parallelograms. So we see parallelograms and trapezoids are not the same. They're both quadrilaterals, but they're different kinds of quadrilaterals. Okay, the same way a rectangle is a special parallelogram, an isosceles trapezoid is a special trapezoid. Okay. And if you see this connection, they're almost trying to make it look like a rhombus is a special kind of kite where all the sides are equal, right? Notice that in a kite, these two sides are equal, and then these two sides are equal, right? And so there's two pairs of corresponding sides that are equal, but you notice in the rhombus, all four of them are equal. So in a square is the most special of all, right? Not only does it have all four right angles, not only is it a parallelogram, but also it's a rhombus because all of the sides are equal. And that's really our definition of rhombus. If you remember what we had here a second ago, right? A rhombus is a quadrilateral where all the four sides are equal. Okay, so these are important. Okay, lately I've been focusing on the sides and the angles, and I've been getting you guys to prepare yourself to start studying the diagonals of all these shapes. This is something that we want to know about. Okay, we can see some of them bisect each other, which means cut each other in half. There's a lot of relationships that we'll study later. For now, we're going to study on sides and angles. Okay, we should be able to see that in a rectangle it's not necessarily true that all the sides are equal, but in a square it is. In a parallelogram, it's not necessarily true that all the sides are equal, okay? But in a rhombus, it is. Okay, and we see a trapezium is kind of like this idea of a shape that would just be a random quadrilateral where nothing's parallel, where none of the sides are equal, where there's no special things about it, where all we know is that it's a four-sided shape and it doesn't fit into any of the other categories. We have this idea of opposite sides being equal. Okay, and we can see that in the rectangle, the square, the parallelogram, and the rhombus, that is true. Okay, but it's not true in the kite. It's not true in maybe some other shapes like a trapezoid. Okay, we see the trapezoid isn't in this table. Okay, then we want to know about the angles. Okay, we know in a rectangle and a square, the angles are all the same. But in a parallelogram and a rhombus, that's not true. In all four of these, the opposite angles are equal. So in a rectangle, a square, a parallelogram, and a rhombus, the opposite angles, meaning the angles that are across from each other, not the ones that are next to each other, but the ones across from each other, are equal to each other. Alright, so this is like what we spent most of our day doing at the beginning before we really started the lesson. So now we want to think about it. What kind of names can we have for this figure? Okay, now if we go back to the definition of trapezoid, I want you to focus on the idea that there's one pair of opposite sides that are parallel. Okay, it's important to think about this right now. Because the problem here with this one is that we know this is a quadrilateral. Okay, so like I've been telling my students on these problems, we want to state all possible names for the shapes that we have below. Okay, this shape has 4 sides. So I can call this a quadrilateral. Okay, but we want to keep getting more and more specific. So what I want you guys to see now is that because these lines are parallel, okay, notice also the shape is rotated. So that might be enough to throw some of you guys off, okay? Notice we have this transversal with 2 parallel lines, okay? Why do I know that they're parallel? Well, the reason that jumps out to me is because we have 60 and 120, and those add up to 180. And because these add up to 180, that means that these same side interior angles are supplementary, and that means that these lines must be parallel. And if they're parallel, that means that this has at least 1 pair of parallel sides, and this is a trapezoid. But now that we take a look up here, we see, wait a second, we see this opposite side that's 8.6 is equal to the other one that's 8.6. So this is a special trapezoid with 2 sides equal. It's called an isosceles trapezoid. So there we have it. This one is complete. These are the most names we could possibly give to this figure, okay? The most specific name is the isosceles trapezoid, and the most general name is the quadrilateral, okay? So go ahead and try the next one. We take a look at 2. What do we see here? Okay, well, let's go back to our table. I want you guys to focus on the definition of kite this time, okay? A quadrilateral where there's 2 pairs of adjacent sides that are of equal length, okay? I think in class I said that the definition was a kite was that there's 2 pairs of congruent adjacent sides. Well, let's look. These are congruent, and because they're next to each other, right, they share that vertex, that's 1 pair of congruent sides. And this one down here, 16 and 16, is another pair of congruent sides. So we have this side equals that one, and this side equals this side. So not only is this a quadrilateral, but because it has 2 pairs of sides that are congruent, that are also adjacent, we call this a kite. Now we had a lot of students having trouble seeing this one, and I think it's natural because we think of a kite as kind of looking like this every time. But it doesn't have to really have that proportion, okay? As long as it has this idea where this side equals that one, and this one equals this one, it's a kite. So for number 2, we should have kite. Now to continue this process, we'll move on and try to give you guys a second to think. So in class, I gave everybody a moment to think about number 3. Tell me what the answer is. It would be a great time to pause the video before I click the answer. The answer for number 3 is right here. It's a quadrilateral. It's a trapezoid again. If these lines must be parallel because 78 plus 102 is 180. And if my same side interior angles are supplementary, that means that these lines must be parallel. So because they're parallel, they're a trapezoid, and because this 10.2 is equal to 10.2 over here, that means we have a special trapezoid that's an isosceles trapezoid. All right, next thing we'll try is number 4. And we could look through the whole list of everything and try to find something that would work here. But in this case, there's no relationships. There's no sides that are equal. There's no angles that are equal. There's no parallel lines then, right? There's nothing that we could really resort to other than calling this a quadrilateral. And that's the answer in this case, okay? Is that this shape is just a quadrilateral. There's nothing more specific that we could call it. And that's the best name that we could do. All we know is that it has 4 sides. Okay, so now we're going to talk about one of the basic things about any 4-sided shape. Okay, any 4-sided shape, if I add up the 4 angles from that shape, they have to add up to 360. So if I add up these 4 angles, right, 1, 2, 3, 4, they have to add up to 360, okay? And the reason is, to make a long story short, is because if I have a 4-sided shape, okay, and if I break it up into 2 triangles, well, think about it. We know that this angle plus this one, right, has to add up to 180. But then we know that this angle plus this one plus that one has to add up to 180 also. And so what's 180 plus 180 is 360. And so clearly if I add up all of these angles going around the shape, I'm going to end up getting 360. So this is kind of an informal proof, just an argument for you guys to understand why we're doing that. Now we're going to go ahead and solve the problem, okay? In this case, you can add up all those numbers, do the arithmetic, and subtract them from 360. And if you add up all of these numbers right here, right, subtract them from 360, you'll have the answer of 104. Okay, so that means that this problem, there was a faster way to do it, and that would have been to know that a parallelogram has opposite angles that are equal, okay? And so that brings me over here to our table that we were looking at for a second, where we saw that opposite angles are equal in a parallelogram, in a rhombus, in a square, and in a rectangle. So we jump back over there, and we just think about this. Well, because this is 104, and this value we're looking for is opposite, it has to be 104 also. So now we'll look at number 6. Okay, take a choice. What do you think the answer is? Okay, we wanted to make this one pretty obvious. I'm trying to beat you guys over the head here with this idea that 100 plus 80 makes 180. There's only two possibilities in a parallelogram. Either these two angles are equal or they add up to 180. We don't really have anything else that could happen here. Okay, so this one has to be 80 because it's opposite from the other angle that's 80. Okay, in this problem that we did in class, we understood the idea before we did the proof. Okay, so I'm just telling you guys as a fact that parallelograms have opposite sides that are equal. So TS equals QR and TQ equals RS. Okay, so we could put this statement, we could write TQ equals RS, and then now I can substitute in those values, right? Because this is equal to TQ, I could go plug that in there, 3x plus 2x. Plus 2, right? And because this is equal to RS, I could go plug that in for RS and write 4x minus 2. So now all we're doing is solving this this equation, but there is one thing you got to watch out for. It's because it says to find RS, but RS is 4x minus 2. So to end up finishing this up, what we're going to do is we'll take away 3x from both sides. And that's going to leave me with 2 equals x minus 2. Now to solve this problem, if I add 2 to both sides, we end up with x equals 4. We're still not done, okay? Notice that we want to find RS, and RS is equal to 4x minus 2, so I can't do that until I find x, and now we found it. So I've been drawing this arrow all day to try to show people, like, look, we're going to throw that in there for x, okay? Usually what I tell my students to do is do it in your head first and then put it on the paper. That way we have an estimate and you can kind of use that to help you understand what you're doing and understand if it makes sense or not, okay? So I'm going to put my 4 in here, but I know I'm going to do 4 times 4. That's 16, and 16 minus 2 is 14, right? So if I put 4 right there, we got 16. 16 minus 2 makes 14. So that's our final answer for number 7. All right, the ideas were similar to what we did in systems. In that last step, number 5, where we got to go plug in our value back into the original equation and figure out what the other coordinate was. It's kind of like that. It's just substitution that we made. So we're moving through this thing now. 8 was a homework problem. Okay, you guys should have been able to set this up as x plus 3 equals 2x minus 4. Okay, and we could say something about this, right? We could say in a parallelogram, right? Opposite sides are equal. Okay, well, if those opposite sides are equal, then that means this is equal to that because those are opposite sides. So I'm going to write x plus 3 equals 2x minus 4. And then to solve this, we'll take away x from both sides, and that'll give me this one-step equation where if I add 4 to both sides, x equals 7. So we want to find VW, but VW is equal to x plus 3. So don't forget again that I'm going to take that value and throw it in there for x. Okay, so we're going to do 7 plus 3, that's 10, right? So I think I'm going to get 10. So now we'll write it. All right, 7 plus 3, and that's definitely 10. So there we go. Okay, number 8 is complete. So now we're going to start moving to the angles. I did number 9 and 10 in class today, so if you were here today, I'll show the answers. At least for 9 was 19. Okay, and for number 10, I believe we did that one too. You should have got 10 for number 10. So now we're on number 11. Okay, this one we also did in class, but I'm going to do this for the sake of the video right now. So we want to understand this process that has to do with parallelograms. Okay, the opposite angles are also equal. Okay, so in a parallelogram, we have equal opposite angles. Okay, I don't want to put any of these proofs into this video. I might start putting the proofs in separate videos later on. So for now, we're just going to work through the worksheet and we'll do the proofs in a different video. Okay, so I just want to make sure you guys understand it. We're not talking about why this is true right now. I'm just telling you this is true about all parallelograms. So it's true now. Okay, those are opposite angles, so they got to be equal. So what I would do is set up 8x plus 5 is equal to negative 5 plus 9x. And then I would just solve this problem. Okay, don't forget that it wants us to find angle E. And angle E is equal to negative 5 plus 9x. So if I take 8x from both sides, this problem is done really quick. Okay, on the left we got 5, we got negative 5 plus x. And now what would have to happen is I add 5 to both sides of this thing. And this is going to give me x equals 10. Okay, we're going to take the 10 and we're going to throw it right there. And we're going to get negative 5 plus 9 times 10. And that's negative 5 plus 90, which is 85. And don't forget it's degrees because we're measuring an angle. Alright, so we're doing alright here. We got number 11 complete, and just realize it's the same kind of strategy as before. So the algebra is the same, but it's the reasoning that's a little different because they're two different facts. You have to know that the sides that are opposite are equal, but you also have to know that the angles that are opposite have to be equal. So if we move on, we can see that number 12 would be a good homework problem. Okay, you would set up 6x minus 2 is equal to 5x plus 7, and then you'll solve that equation. And you'll go plug that number back in here to figure out what 12 is. So I don't think I could do 12 right now. You guys got to have one that you try. All right, 13, I can't do that one either. You guys kick that one on your own. Okay, but 14, we'll do together right now. Okay, the thing that we want to know about parallelograms is that the consecutive angles have to add up to 180 here, right? So these two, because it says the word parallelogram here, okay, that means that these two angles have to add up to 180. So what I did today was I had students write the measure of V plus the measure of W is equal to 180 degrees, right? And then we'll go plug in those values. V is equal to 10x and W is equal to 12x plus 4 equals 180. And if we add those up, that gives me 22x plus 4 equals 180. And now, there we go. If I take away 4 from both sides, we got 22x equals 176. If I go ahead and divide 22 by both sides, we get x equals 8. And then we know we have to take that value and go plug that into our expression for w. Okay, so w is 12x plus 4. So I'm going to take that 8 and I'm going to plug it in there. Okay, so I know 12 times 8 was going to give me 80 plus 6 is 96. 96 plus 4 is 100. So I think I'm going to get 100. Okay, and we can go do our work right now to make sure that that's right. Okay, let's think. 80 plus 16 is 96 plus 4. That equals 100. Okay, and don't forget that this is degrees. I almost forgot. Okay, so we need those degrees there too because we're measuring angles. All right, so this problem is not complete. We're getting closer to the end here. And the video isn't too long, so I'm hoping some of you guys could watch this if you were out and it could help you out. Okay, now in a trapezoid, we need to remember this simple thing that I did in class where I showed everybody that we have to know a trapezoid has one pair of parallel sides. So that means this side is equal to that one, parallel to that one. And if I extend the lines, it might start to activate some of the knowledge that you guys had when we studied parallel lines. Okay, so let's try to reactivate some of that knowledge that's there in your brain. Okay, we have this line crossing right here, okay? And we learned corresponding angles were the most important things in parallel lines, right? That was our postulate. And so if those two corresponding angles are in both 46, that means that the red lines are not parallel, right? They'll crash into each other. They have to be going the same direction to be parallel. So now, what would this question mark have to be? Well, we have to remember that those two angles have to add up to 180 because they're both on that straight blue line. So that means this angle has to be 134, which brings me back to this picture that I've drawn a lot for you guys on the other problem. So if you're like needing to study parallel lines, this is very important. You definitely might want to go back, especially if you were like maybe really absent during that part of the year, or maybe you're a new student. Watch that part again, okay? Remember that with parallel lines, there's really only two relationships that happen. Okay, we got the corresponding angles are all equal, and we got the supplementary ones, the ones that add up to 180. Okay, so there's only two possibilities. Either the numbers add up to 180 or they're equal. And you have to know which one is which. So there was a lot of vocabulary that goes along with that. Okay, in this case, we called these two angles, we called them same side interior angles. If you guys could remember that, okay? And we said same side interior angles are supplementary, which means that they add up to 180. Okay, so that's something that's a fact that you want to be able to access pretty quickly. So you want to be clear about parallel lines. So maybe go watch one of those videos if you feel like maybe you're shaky about parallel lines. That would be the place to start. Okay, so for 16, what do you got for this? Okay, well, 180 minus 95, that's going to give me 85. Okay, you might want to pause the video though. We're going to do these ones quick. Okay, so pause the video if you really want to try to get this problem. Okay, we would have to know that these two add up to 180. So one way to do our work, if we want to show algebra, okay, plenty of people are just going to do 180 minus 135 right there, okay? But it would be nice for you guys to understand how to form this equation, that those two angles have to add up to 180. Again, why is this true? Because these are same side interior angles, all right? And because those lines are parallel. Wait, why do I know those lines are parallel? I don't see any marks here. Oh. It's because of this word, trapezoid. Okay, you have to know that trapezoid means that there's one pair of parallel lines, all right? So we have those same side interior angles, and they have to add up to 180. So clearly, you go ahead and subtract 135 from both sides, and you'll have the final answer of what x is equal to, all right? The next thing we're going to do will be to move on to slightly more difficult problems, all right? So this one, again, you'll have 100 for this one because these two have to add up to 180. So I hope that's obvious to you. For 19, I did this one in class, okay? So we would add up these two values. These two expressions, and have them equal to 180 to do this one, okay? So we're going to say that this plus this equals 180, okay? And the reason that we could say that is because we could say the measure of u plus the measure of angle t is equal to 180. And again, what is the reason? Yo, this is same side interior angles, okay? For the 5th time, I'm really trying to make sure you guys could recall that fact, okay? Same side interior angles, it's really not that confusing, but I know there's two possibilities, so you just have to try to not get confused, okay? Sometimes they're equal, and sometimes they add up to 180, all right? And this is the one where they add up to 180. So I'm going to go put in the different expressions, okay? We'll plug that in for u. We got 6 plus 7x. And then for the measure of t, we're going to plug in this expression right here, 33x plus 14. Okay, now to simplify this, we're going to combine like terms. So I can only combine the x's and the x's, right? So 7x plus 33x is going to give me 40x. But now when I combine the 14 with the 6, that's going to give me 20. And it's all equal to 180. So working through this problem now, what that means is going to happen is I'm going to subtract 20 from both sides. And then 180 minus 20 gives me 160 degrees. And it looks like this is going to be divisible by 40, won't it? Okay, so that's a good sign. If we were to get a value that didn't look like it was going to be divisible by 40, that's when you want to try to find your mistake, okay? Because that wouldn't be the way that these problems work out. At this point of the year, I still haven't given you guys anything that's really that challenging numerically, all right? We're focusing on the concept here, okay? But pretty soon, we're going to have to include a lot more fractions. So we'll have to start playing hardball pretty soon, you got me? So to finish this up, we're going to go take that and plug it into the expression for angle u. Angle U is 6 plus 7x. So I'm going to go plug in x is 4, okay? And I know that 7 times 4 is 28. 28 plus 6, I'm doing it in my head, is 34, okay? Now we'll do it on the paper. We got 6 plus 28, yeah, 34. Okay, so that problem is complete. That's 19. Now we're at the last problem of the day. This is probably a great one for you guys to do, okay? I don't like to do every single problem on the homeworks, okay? But I will set you guys up at least, okay? To do this problem, don't forget the first step that I kind of keep being impatient and I keep forgetting to go here and write the first thing, okay? I was telling you guys lately to do a problem in this section of the class, okay? You guys want to follow the steps. Read, label, and think. I know it's kind of comedy. It's kind of meant to be a joke a little bit, but I am serious, okay? Think means you have to try to notice something, okay? You have to process things. You have to let thoughts swirl around your brain, okay? So you can't just sit there and stare at stuff. You got to make sure there's thoughts happening in your brain, okay? We read the thing. It says that this is a trapezoid. So that means that there's one pair of parallel lines. Those two things are parallel, okay? We just labeled the picture, and now we're going to think, well, it wants me to find the measure of angle J, but the measure of angle J is 10x, so I'm going to write 10x right here. If we knew what x is, I would just have to multiply it by 10, but we don't know what it is yet. So now, we get to the next step, okay? We're going to have to form an equation, okay? After we form our equation, then we have to solve it. After we solve that equation, we're going to go substitute that in to our old formula. In this case, this one right here, the one that we started with. We're going to find our x, and we'll plug it back into that one, and we'll be done. Okay? So the thing that you have to remember is that in the trapezoid, right, again, we have parallel lines, and these are same side interior angles. So the measure of angle K plus the measure of angle J is equal to 180 degrees. But K is equal to 28x minus 10, and J is equal to 10x. So now what happens if we add those up? We get 38x minus 10 equals 180. You guys could take it from there, okay? You guys are in a good situation to wrap this problem up. So I hope you guys do have the answer key that I'll post up, but don't forget that it's all about the steps and asking questions so you understand how to actually do the problem. All right? Let's project the answer key up here. Okay, so this is like meant to be a real introduction to some of these shapes, getting to know the ideas behind them. We got a lot more to do about proofs and everything, so, you know, good luck getting through this first introduction homework.